welcome back. Sorry you couldn't hear me. Hopefully you can hear me now. Morning. Joe, it's gotta be all done by tomorrow. All done by tomorrow. Yes. You're welcome. All right, Leonardo, thank you for letting me know. Welcome back. All right, good morning. Welcome back. I hope you guys are doing well. I hope you had a great weekend. Hopefully you're nice and warm. It's freezing out there today. Hopefully you turned in your guided notes. Hopefully you finished up the exit pass on hydrogen and metallic bonding and everything else that's going to be completed or was supposed to be completed. If not, by tomorrow, keep delaying this deadline because we're in the virtual world now. By tomorrow, your assignments have to be turned in, your exit passes and your guided notes. So exit passes and guided notes have to be turned in by tomorrow. I have started checking out some guided notes. It's taking me forever. Like your guided notes are 30 pages. So I have to scroll through everybody's stuff. And again, that's about 100 points. So I definitely will be busy today. Get all your work in by today. What am I grading for the quarter? Your exit passes for ionic bonding, covalent bonding, hydrogen bonding. Definitely grading your ionic bonding, covalent bonding, Unit 5 guided notes, Unit 4 guided notes, and I can't recall if Unit 3 is on there as well for guided notes, but your guided notes must be completed, and obviously your midterm will be on the quarter as well. Does anybody have any questions for me or anything you want to discuss before we jump start to today's class? Typically, Jumila wants to know, am I going to let you know your grades when you're done with them? Overall grades, I would have given you a printed out hard copy of all your grades if we're in school. I'm trying to figure out the best way to send up your grades. It's a little tougher for me to do it the digital world for your overall grades to show you it all. So I don't like to have surprises for you guys. I want you guys to know what you have, but I'm still trying to figure out this routine to get you your own grades to you. Yes, I could download all 90 of my students' quarter 2 grades and send them to you, but it seems a little, maybe I'll do that. I'll have to think about that one. Good question though, Jumila. Will I get your grades? Maybe in a breakout room. That might be the best thing to do. Maybe a breakout room one day, show you your PDF. I'll think about that. All right, anything else? But Jumila, you're highlighted today. The flow chart. So you're just looking for a hard grade, that's it. All right, thanks for the ideas. All right, let's just check out what's going on for today. Today's the last day before the midterm, so it's a lot of questions we're reanalyzing. So let's get right to it. The dashboard, let's check out the Oneida County coronavirus dashboard. At this time, I guess it's a good thing today. There's 7,207 active cases, but we have more resolved cases than the active cases. So that's a good news. I don't think I've seen that before. We have more resolved cases than active cases. So hopefully we're heading in the right direction for the second wave. There's 317 people who have passed away through COVID. Hospital systems, there's 154 people in the hospital, 24 people in ICU. Obviously, you can see the vaccinations below. I'm not going to go through those numbers. But the daily positive cases of COVID, what happened over the weekend? I think you could check out this curve. I think you could analyze this curve and check it out and say, oh, first wave, done and over. Didn't really hit us too hard. Now you say that. Now you say it didn't hit us too hard. And then the second wave starting to form. This is a rough estimate from what I see. Should be a little higher there. But it looks like from all this data, I don't know. It looks good. Looks like we're doing something right here. It looks like the second wave is starting to descend. So last week's data was amazing. What could happen here on out? It could flatten out. It could go back up, or obviously go back down. 3 different things could happen there. So hopefully we continue in the downward direction of this curve. So there's some data. Check out the last couple of days. The 23rd, there's 115 cases. And the 22nd, 184. Still a ton of cases, though. But it's looking better. Just continue to practice social distancing, wear a mask, protect yourself, protect your loved ones. Hey, Alex, welcome. Try to get here a few minutes earlier, please. All right, let's check out what's going on for today's class. Quote of the week. Welcome back. Happy Monday. If your dreams don't scare you, then they're too small. Richard Branson said that quote. If your dreams don't scare you, then they're too small. So you have one shot to go through life. You have one shot to go through and make the most out of it. Learn the most from life. Make the most out of what you're going to be or who you're going to be. Dream your dream. So make some dreams, accomplish those goals. Put some goals out there for you. Check them off. Get there. Hopefully have a nice career. Hopefully you'll have a nice life for you as well. It all starts right here. All right, big daily agenda for Monday, January 25th, 2021. Today's a day one. It's midterm review day. So midterm is next class. We're going to continue on with units number 1 and 2, and then we'll follow up with unit 3 and 4. The exit pass, it was due last week, but I put up here as well. Your midterm is tomorrow. It is 45 multiple choice questions. You have 1 block to complete the assessment. So you cannot start the assessment at 12 o'clock and say, hey, forget it. I'm just going to do it at 8 o'clock tonight. No. Once you start it, you have to finish it. It's 45 questions and 84, maybe 80 minutes to complete the assessment as well. Once you start it, you have to finish it too. Here's a reference table for today's review. Feel free to use that. And let's just get right to it. So please find Unit 1, Unit 2, midterm review. The date might have been due last week, but I'm going to go through and complete this right now. So don't worry about submitting it. It's not getting graded towards your grade. We're doing it together. It's a review. So review is a lot of time I won't grade. So please click on that. We left off on question number 16. Give you a minute to catch up there. Figure out where we are. I'm not going to give you time to work on this independently right now, like 10 minutes by yourselves. I'm just going to go right to it and just start answering these questions as quickly as possible. Yes, it is just multiple choice. Just multiple choice questions for the midterm. They're all like these, similar to these. They're all Regents style questions, I'll say that. They're not exact Regents questions, some of them are. They're Regents types or style questions. Yeah, Jordan, I could privately message you guys your grades once they're completed. But it probably will not be completed till, honestly, this week, by Friday or Saturday. They're due, all grades are due by Friday at 4:30. So since our midterm is this week, I'm probably gonna have some students taking it Wednesday midterm if there's people sick. So I will not release them until everybody's done with that. All right, here we go. Question 16. Hopefully I have enough time to find this. This is units number 1 and unit 2. Unit number 2 specifically. 16 says the accompanying graph represents a heating curve of a substance that starts as a solid below its freezing point. What is the melting point of the substance? I will give you time to try these out. I'm going with 30 seconds to jumpstart today's question number 16. Try it out. Okay, question number 16. Please put the answer in the chat. Best response for this one, please. All right, several of the same answers. So here we go. Let's review this. Checking it out, we have temperature on the y-axis and time on the x-axis. It says a solid, starts off as a solid below its freezing point. So we know it's going to be a solid first. We know the phase in the middle is a liquid, and the last one's going to be a gas. We want to know the melting point of the substance. Take an ice cube out of the freezer, leave it on the countertop. It's going from a solid to a liquid. So that phase, that segment right there, represents melting or heat of fusion, or it could be freezing in the opposite direction. So wherever that temperature of 55 is the melting point of the substance. Again, I would not expect to see heat of fusion on this assessment or heat of vaporization. The other chemistry teachers teach it during quarter 3. Probably the third benchmark you'll see at questions regarding heat of fusion and vaporization. Number 16, the best answer is C. Next up, 16, the best answer is B, 55 degrees Celsius. B. 17, which sample of iodine will sublime? Which one has the ability to sublime? 25 seconds. Please put the answer in the chat. Which one has the ability to go through sublimation? So again, you had to memorize what sublimation was again. 17. Think about sublimation. I think of sublimation with this heating curve again. Solid, liquid, gas. Sublimation starts with an S. So its phase starts with an S. It's a long word. So it's going to be a long jump. Starts with an S, long jump, goes all the way to a gas. So which one has the ability to go to sublime, go through sublimation? It has to start with S, and then go to the gas. So it's going to be a solid. Choice D is the best answer for number 17, because it's starting with a solid. This, if it asks which one has the ability to go through deposition, it says subliming. Gas to a solid is deposition. Liquid, no. Aqueous, no. 17, the best answer is D. 17 is D. Number 18, the particles in a crystalline solid are arranged, 20 seconds. Solid particles, the arrangement is? Please put the answer in the chat. That's my best little dots of a solid particle or crystalline structure. Crystalline is going to be a solid crystal. Crystal structure or solids look like kind of to the left. We drew this. I have the notes up here. All right. Thought I had them up there. I'll pull them up in a second. So solid particles, we drew it in class. I think it was unit number 2. Solid particles, a lot of the same answers. D, regular and close together. So there's going to be a tight arrangement. These particles don't really move from one spot to another, and they're really close together. Choice D is the best answer for number 18. D for 18. Number 19, which set of properties does the substance of CO2 gas have? So CO2 gas. What are properties of CO2 gas? 20 seconds. Please record your answer in the chat. Okay, a lot of D's for this one, and some C's. When I think of a gas particle, I think of this little diagram, maybe a number 5 dice, but particles really spread out pretty far in a gas. What happens, they move in a straight line motion until they hit like a barrier, then they reflect on off. Or if they hit another particle, what happens is they hit and it transfers all of their energy. They take the shape of the container. They're constantly moving. They're randomly moving. There is no definite shape, definitely. And could you measure the volume of a gas? If you blow up a balloon, is there a volume in there? Yeah, there's a volume in there too. So there's a definite volume for a gas. No definite shape, but a definite volume. There's a measurable volume in a gas. That one right there, check that one out. That one's best answer is going to be choice C. No definite shape, but a definite volume. 19 is C. All right, next one up, number 20. Which diagram best represents a gas in a closed container? Closed container, which one represents a gas? I think we could see that one. Best answer here is going to be choice A. Kind of looks like the diagram to the left. So A looks like a gas. B might be like a liquid. C might be a solid. D would be if this cap was removed, then gases would try to escape. So if I pop this cap off, take the cap right on off, then these gas particles would try to escape as you opened it on up. So I'd go from a high pressure system, like you open up a can of soda, you hear a tss. As you open it, you have the CO2 escaping. It's going from a high pressure system to a lower pressure system. So this question right here, number 20, best answer is A. 21, which statement best describes the shape and the volume of an aluminum cylinder at STP? Shape and the volume of aluminum cylinder at STP. 25 seconds. Please record your answer in the chat. So aluminum cylinder, there's this little cylinder there, like a graduated cylinder type of thing. If you wanted to find, there you go, there's aluminum cylinder. Has definite shape and definite volume. You could measure, you could take some math, you could measure the volume of this, use some geometry. Another way you can find the volume, does it have a definite volume to that, is you can use displacement of water. So what do I mean by that? So if they ask like a density question and they need a volume, you could take the displacement of the liquid. So if I took a graduated cylinder, take a nice picture of a graduated cylinder. That one's a cute one for me. So if I take a graduated cylinder, this one looks like it has not much volume in there. So 10, 15, maybe 16, maybe 17. I don't know. We'll assume it has 17 milliliters of water. So if I have 17 milliliters of water in this initially, I'm going to call this my volume initial, VI. Volume initial equals 17.0 milliliters, say. If I take a aluminum cylinder, if I want to figure out the volume of the aluminum cylinder, here's my aluminum cylinder, and I don't know the volume, and I don't have a ruler. If I take that aluminum cylinder, if I drop it inside of the graduated cylinder, what's going to happen? Put this on in. If I drop that on in, drop. There it is in the bottom. You really see it. Drop it in again. Same cylinder, drop it on in, boom. What's going to happen? The water is going to be displaced at a higher level. So it's going to be more water. So I dropped it in. What's going to happen? We'll assume it went all the way up to this point, right there. So now the water went higher. Now our volume final, VF, we'll say it's equal to 20.0 milliliters. So now you can figure out the volume by displacement of water. So I dropped it in. If I subtract those two values, that cylinder has a volume of 3.0. So you can do it that way as well. So it's called by displacement. Volume by displacement is called. So that one right there has definite shape and definite volume. Best answer. Question number 22, definitely need a reference table. At STP, which list of elements contains a solid, liquid, and a gas? At STP, which list of elements contains a solid, liquid, and a gas? So take our reference table. I'll give you 1 minute, maybe 90 seconds actually. Try this one out. Okay, please record your answer in the chat. Best response, please. All right, cool. Thank you very much. So a lot of responses. Thank you for our participation. Checking this one on out, we have, the first thing I would do is I highlight the elements, figure out where they are. You should know the two liquids on the periodic table. The two liquids on the periodic table, first one's going to be mercury, the stuff they used to use in thermometers, which is, I'm going to call it brown. And the other one is my element, which is brown bromine. Two liquids, definitely know. There's a question on the midterm on identify a liquid on the periodic table. No, mercury and bromine, two liquids. Other thing you should know are the gases. So where are the gases located? They're starting at nitrogen all the way over to neon. So everything in red's a gas. Noble gases are gases. You see how that 7 forms. You have hydrogen's a gas. Helium's a noble gas. That's a gas. And then chlorine is a gas. So again, see that 7. So no other fools are gases. Noble gases are gases. Hydrogen, helium, and chlorine. Everything else is going to be a solid at STP. A lot of you guys pick choice A. All the pinks that I have here, they're all They're all highlighted for you. HF, solid. Hg, liquid. He, gas. 22, best answer is A. 22 is A. 22A. Next up, number 23, the graph below represents uniform heating of a substance starting below its melting point when the substance is a solid. Okay. Which line segment represents an increase in average kinetic energy? Which one represents an increase in average kinetic energy? Please try it out. 30 seconds. Please record your answer in the chat for question 23. Nice. So far, everybody that submitted an answer put choice B. You have to know what average kinetic energy is. The average kinetic energy is temperature. So which one has an increase in temperature? So average kinetic energy is temperature. Which one's in temperature increases? You can see on the y-axis. Checking out the temperature, we have the first phase, A to B. Maybe it's starting off at 0 degrees Celsius. Maybe it goes to 20 degrees Celsius. There's a change in temp there. A and B, definitely a change in temp. If we check out segment BC, BC has a phase change. The temperature remains constant. Temperature remains constant at DE as well. So anytime you have a phase, the temperature is going to change. B is the best answer. C and D, obviously you have a phase change. EF, you have C to D, you have temperature change. E to F, you have a temperature change as well. Little quick review for this segment here. A and B, the kinetic energy, A to B, kinetic energy increases. Potential energy, the phase remains the same. The same thing for C and D. Kinetic energy increases. Potential energy remains the same. And the same thing for E and F. Kinetic energy increases. Potential energy is the same. So I told you to memorize kinetic energy first. Think about it. Temperature is changing. Kinetic energy is increasing. Then you'll know the opposite one. So the opposite segments here, if you're going through it, B, C, that kinetic energy, the temperature is the same, but potential energy increases. Why? Because it's going through a change in phase. The same thing for D and E. Kinetic energy is the same, temperature is the same, potential energy is going to increase. Why? Because it's going from a liquid at D to a gas at E. Hope you remember that curve. Might be a question on that. I don't think so, though. Might be quarter 3 again. All right, so that answer, best one was choice B. Number 24, according to the kinetic theory of gases, which assumption is correct? Talking about gases, which assumption is correct? 20 seconds on the clock. Okay, that's your 20 seconds. Please put your answer in the chat. It's great to see a common trend of answers. All right, a lot of you guys said choice D, and some of you said choice C. All right, so there's a gas particle or gas diagram. Gases move in a straight line motion until they hit a barrier or another particle. They take the shape of the container. Once a particle hits another particle, what happens? It transfers all of its energy. So it's called elastic kinetic energy. So it's going to transfer all their energy. That is the best answer, choice C, because it's talking about that. Gas particles prevent. No, it doesn't prevent random motion. They're gonna be in random motion. So prevents random motion would be like solids. Solids would be in nice tight configuration, real close together. Speaking of hearts. So that answer is definitely gonna be choice D. I'm going off a little bit. I'll come back to this in 1 second. Just have to really express this with you guys. If you're looking for a Valentine, or if you have a Valentine and you're looking for something nice to relate to, or something nice to put in your Valentine's note, you could definitely put some of these in there. I'll put those actually on the stream once in a while. Let's go through a couple of these. Found this up here. You could make chemistry like poems to each other. You are like fluorine, iodine, neon. Fine. Happy Valentine's Day. That's a cute one. That love. Hey, Copper. Yeah, I see you in my dreams. Get it? See you in my dreams? That's a good one. This is a good one, too. All this love for bonding. All this chemistry you guys have now. You have all this chemistry. You can use any of these jokes, any of these little poems. Feel free. You can make up your own poem related to chemistry. That's awesome. They're kind of cool. Oh, that number 3 is a cool one, too. 4,930 has 3 sig figs, but I simply have 1. You're the only significant figure in my life. That's all that counts. That's cute. Whatever. All right. So you could write a poem for your boo. I do every year for my wife, and she loves it. Absolutely loves it. Oh, get these hearts out of here. Enough of that chemistry love. Can't get rid of them. All right. Oh, sorry, get off topic, but that heart they threw me off. All right, so that was the let's see, talking about kinetic molecular theory, and D was the best answer. Oh, good. We're done with units number 1 and 2. You can submit it. You don't submit it. I'm not grading it. That was a review. So unit 1 and 2 is done. That was our second round of units number 1 and 2. So we're set with that one. We're moving on to the next unit, which is 3 and 4. Please find unit 3 and 4, midterm review. And we'll continue the same trend until we get to the end of this. So I'll give you a small segment of time, and then we'll review it as well. So please click on it. Good that none of you did it. And this is units 3 and 4. If you remember unit 3 and 4, unit 3 was the atom, unit 4 was the periodic table. This again is our second round with unit 3 and 4. We've already went through a review for unit 3 and unit number 4. If you want to take out your guided notes, feel free to. I'll pull out someone's notes. There's a few samples. Let's go Nadina's. Pull out Nadina's notes for reference here. And I'm also going to pull out unit number 4, the periodic table. So I guess it's cool that you're in the virtual world. You could pull up all your notes, whatever unit was. See if Joseph did it. What? This is the atom. All right, I'm not going to search too much. Just going to pick a random one. All right, so you can use your notes if you need to as well. All right. So hopefully enough time to open up your file. Maybe you want a periodic table as well. First off, we're starting with unit number 3. All right, question number 1. Experimental evidence indicates that the nucleus of an atom, what? Nucleus of an atom, what? Let's give you 30 seconds to try this out. Okay, please put the answer in the chat. Experimental evidence indicates that the nucleus of an atom a couple different answers that we have here. Contains most of the mass or contains a small percentage of the mass. Best answer is going to be choice A. Contains most of the mass of the atom. So in the nucleus of an atom are the protons and neutrons. Rutherford actually went through this. He said small, dense, positive core. Dense means it's going to have a great mass. Most of the mass can be within the nucleus of an atom. So again, if you remember the nucleus or nucleons, let me scroll on down. Nucleons are protons and neutrons. And nucleons, protons and neutrons, have a mass of 1 AMU for protons, 1 AMU for the neutrons. Both those guys have majority of the mass. A is the best answer for number 1. 1 is A. Number 2, an experiment using alpha particles to bombard a thin sheet of gold foil indicated that most of the volume of the atom in the foil is taken up by what? 25 seconds. Please record your answer in the chat. Number 2. All right, a couple different answers. Most of you guys put choice D, which is correct. If you're analyzing this question, here's Rutherford's gold foil experiment. Within the Rutherford's gold foil experiment, what happened? Particles were shot from a laser. Most particles went right through the atom. That's a gold foil. But what else happened? Sometimes particles hit the nucleus and deflected off. But since most particles went right through, the atom was mostly empty space. So most of the foil is taken up by empty space. Number 2, best answer is D. 2 is D. Number 3, next question reads, the modern model of the atom is based on the work of modern model of the atom is based on what? 25 seconds. Please record your answer in the chat. Number 3. Cool, everybody put D so far. So many scientists over a long duration of time. The history of the atom started off with the Greeks. After the Greeks, Dalton started in 1803 with Dalton's atomic theory. He said the atom is just a solid sphere. Then J.J. Thomson, 100 years later, came up with a cathode ray tube experiment. He discovered the electrons. He also said the plum pudding model. So electrons were randomly distributed throughout the atom. Then Rutherford said use the gold foil experiment to prove the existence of the nucleus, solid, dense, positive core, but mostly was empty space. Then Niels Bohr came along and said the nucleus is a solid, dense core. Okay, but electrons orbit in rings. Then the wave mechanical model, SPDF, that's where we're at today. Maybe we'll change it. It's just electrons travel in paths like S, P, D, and F. Best answer for number 3 is D. Number 4, wave mechanical model. An orbital is a region of space in which the atoms, where there is what? 20 seconds. Please record your answer in the chat for number 4. Yeah, it's easy when I have the notes right there for you. Hopefully you know this as well. But it's in the notes. I'm showing you that you can find it in your notes. Orbitals a high probability of finding electrons. Choice A is the best answer, number 4. 4 is A. Number 5, which sequence represents the correct order of historical developments leading to the modern model of the atom? Which is the right sequence? 30 seconds. Please record your answer in the chat. Best answer for number 5. Okay, several answers are A. Some people put A, some people put C. A and C. All right, if I'm checking out this question, talking about the atom, start off with Dalton. Dalton had the cannonball theory, where it's a solid, dense sphere. And then it went to Rutherford, where it said atoms mostly empty space. And then they said electrons travel in rings or orbits or orbitals. SPDF. Choice A is the best answer for number 5. A for number 5. Number 6, the nucleus is part of the atom that what? What is a nucleus here? 20 seconds. All right, please record your answer, number 6 in the chat. Couple different answers again. That's okay. The nucleus. Inside the nucleus, here you go. Nucleons are protons and neutrons. Let me draw a nucleus again. All right, so my atom has a nucleus. Here's a nucleus. Inside the nucleus are my protons and neutrons. So protons, P positive, and neutrons, N 0. Protons and neutrons make up most of the mass of the atom. Protons have mass of 1 AMU. Neutrons have mass of 1 AMU as well. Electrons are so small they don't even take account for the mass. So this question should be mostly empty space. Contains mostly empty space? No. So it's not most empty space. It's a dense solid core. Negative charge? No. It's a positive charge. You can see the positive right there. Total volume would be incorrect because this is all volume with electrons. Most of the volume is my electron cloud. Contains most of the mass. Yes. Choice D is the best answer for number 6. 6 is D. 6 is D. 6 is D. 7. Here we go. Which particles are found in the nucleus of an atom? I think you only need 10 seconds for this one. It's located in the nucleus of an atom. Question number 7. Please record in the chat. Yeah, D. Protons and neutrons. 7. Best answer is D. Number 8. Which statement best describes the nucleus of an aluminum atom? Nucleus of an aluminum atom. 35 seconds. Please record your answer in the chat. Number 8. Several B's as answers. Here we go. Inside the nucleus of an atom, we have protons. Where are the protons? Protons are going to be the same thing as the atomic number. So find the atomic number of 13. That's how many protons you have there. So again, inside the nucleus, you have protons and neutrons. Protons are positive. Neutrons are neutral. We have 13 positives. I don't even care how many zeros we have. We have 13 protons, positive 13. And how many electrons are there? It's an atom. Since it's an atom, you're going to have the same number of protons and electrons. So 13 protons, 13 electrons. 13 protons, 13 electrons. Choice B is going to be the best answer for number 8. 8 is B. Atom. Atom versus ion. An atom's neutral. There it is. An atom is neutral because the protons and electrons are equal. An ion is charged atom. It has a positive charge or negative because he either lost or gained electrons. So anion's negative means it gained an electron. Take an electron on, it's negative. Cation, metals, are positive because they throw away an electron, negative charge off it. Best answer here is going to be choice B. Number 9, in which pair do particles have the same mass? Approximately the same mass. 30 seconds. Please record your answer in the chat. Yeah, same mass. Looks like B. A lot of you guys put B. If you forgot this answer, forgot this question, you can find it on the reference table. You can use table O of the reference table. Here's table O. And in this table, you can analyze different subatomic particle properties. So you have electrons there, you have protons, you have neutrons. Which one of the subatomic particles have the same mass? Mass is upstairs, as a mass is 0 for electron. neutrons have a mass of 1 AMU. Protons have a mass of 1 AMU as well. So obviously protons and neutrons have the mass of 1 AMU. 1 AMU. Or find in the notes, 1 AMU, 1 AMU. Protons, neutrons. Number 9, best answer is protons and neutrons. Choice C. Number 10, an atom of any element must contain 25 seconds. Please record your answer to number 10 in the chat. Yeah, B is the best answer. Thank you. B, the equal number of protons and electrons. Neutral atom, protons, and electrons are equal. Number 11, all phosphorus atoms have the same 30 seconds. Please record your answer, number 11, in the chat. Tricky one. All phosphorus atoms have the same what? So if I'm checking out phosphorus, it's P. The number in the bold number, 15, is my atomic number, or it's equal to my proton number. It is always going to be the same for whatever phosphorus you're talking about. So atomic number looks like a solid answer to start off. The mass number. So an isotope is the same element, but a different mass. So that mass can be different for an isotope of phosphorus. That number could change. No. Number of protons, number of neutrons plus the number of electrons. Neutrons come from, how do you find neutrons? Neutrons are mass number minus the proton number. If I use mass minus proton number, if the mass is different, then the number of neutrons is going to be different as well. So the number of neutrons is going to be different. That's not going to be the best answer. And the last one, the number of neutrons and protons, that's going to be different because the number of neutrons can be different for isotopes. Best answer is choice A for number 11. That's all right. Number A for number 11. 11 is A. Next up, number 12. Which diagram represents the nucleus of an atom of aluminum 27 over 13? Al 27 over 13. 30 seconds. Please record your answer in the chat. Okay, I get a ton of responses for this one. which diagram represents a nucleus of an atom of aluminum 27. So again, let's zoom in on this for a second. The number upstairs represents the mass. So that number on top is the mass. The number on the bottom represents the proton number or the atomic number. Let's go fall on you. Fall colors. All right, so this is my proton or atomic number. So that number on the bottom has got to be proton number. So there's got to be 13 protons. From that, I could get rid of choice A. There's not 13 protons. Next up, inside a nucleus are protons and neutrons. How do you find neutrons? It's the mass minus the proton number. Take 27 minus 13. 27 minus 13. The best answer is going to be choice B, 14. 14 neutrons, 13 protons. 14, best answer is B. 12, the best answer is B, not 14. 12, the best answer is B. Next up, 13, what's the approximate mass of an atom that contains 26 protons, 26 electrons, and some neutrons there? Where's the last one? 19 neutrons. What's the mass? 30 seconds. Please record your answer for number 13 in the chat. So I highlighted this in the notes. Mass number, the mass of the atom comes from protons plus neutrons. So all you gotta do, Santino, is add up your protons plus neutrons. Mass comes from protons plus neutrons. Protons and neutrons have the mass. So take 26 plus 19, that's going to give you 45. Choice B is the best answer for 13. Number 14, atoms of metallic elements tend to do what? Metallic elements tend to do what? 35 seconds. Please record your answer in the chat for number 14. Okay, not a ton of responses for this one. Metallic elements tend to do what? So checking it out. Everything in the pink highlight is a metal. My metals should be able to get the charge. Most metals have a positive charge. All metals have a positive charge. Hopefully you can follow that. Metals have a positive charge. Okay. Positive ion. Positive ion. We have a 50% chance to get this right now. It's not going to be choice C. Not choice C. It's not choice A. It's not negative. Those are nonmetals. How do you get a positive ion? Why is it positive? Why is that a positive 1? Why is it positive 2? Because you want to get to a stable octet. So that one valence electron that was there, or the 2 electrons that were there, say, see you later. I'm out of here. I want to be stable. So these electrons leave the form of the nonmetal, or maybe a metal. But as they leave, they form a positive charge. These positive charges are formed when they lose electrons. So lose electrons, form a positive charge. Choice D is the best answer for number 14. 14 is D. 14D. Number 15, how many electrons are in Fe plus 2? Fe plus 2. 25. Please record your answer in the chat for number 15. Yeah, plus 2 means you're not adding 2 electrons. It means you're actually taking 2 away. How many electrons are in Fe atom? 26. That plus 2 means you lose 2 electrons. So those 2 electrons at the end, they're gone. They're leaving. So as they leave, you're left off with 2, 8, 14. Best answer is choice A. 15 is A. Next up, number 16. Which subatomic particle is found in the nucleus of all isotopes of hydrogen? 20 seconds. Please record your answer, number 16. Yes, Emma? Tintin, good. Choice A. Best answer is protons. Protons. There's always going to be 1 proton in hydrogen. The number of neutrons can change because 1, if you find neutrons for this one, it's 1 minus 1 would be equal to 0. So H1 is going to have 0 neutrons. So protons is always going to be found. Choice A. Number 17. Which statement best explains why most atomic masses on the periodic table are in decimal form? Why are these masses in decimal forms? 30 seconds. Please record your answer in the chat. Okay, I just found in the notes as well. Right to the left, I highlighted it. Atomic mass is the weighted average of an element's naturally occurring isotope. So there you go. So choice C looks like a solid answer. It's the weighted average of the naturally occurring isotope. So remember how to do the masses. Take a look at that. Make sure you can calculate the mass. I think there's at least one question similar to calculating atomic mass. 17, best answer is going to be choice C. Number 18, elements in period 3. Oh, now we're talking about the periodic table. Elements in period 3 has the lowest ionization energy is what? Before I get to this, let's pull out a reference table. Let's analyze some trends of the periodic table. There's 4 trends that you should definitely be aware of for the periodic table. You can use page 10 and 11 to help you out. We're definitely going to look at ionization energy, electronegativity, and atomic radius. So the 4 trends: radius, electronegativity, ionization energy. The last one is metallic characteristic. The first one that we analyzed in class was atomic radius, the size of the atom. So how does the size of the atom work out? As you go down a group, the size increases because you add more and more rings. As you go across a period from right to left, the size increases. So again, the tip of my arrow gets bigger, gets larger. So this red one, maroon one, is going to be the atomic radius, the size. Which one has the greatest atomic radius? It's going to be francium. The greatest size, the biggest atom, is francium. That's atomic radius. Next up, we analyzed electronegativity a lot. Electronegativity is the attraction for electrons. How does it work? As you go across a period from left to right, these guys want to gain electrons, or it's easy for these guys to gain electrons. Why? Because there's 3 valence electrons, 4, 5, 6, 7. If you have 7 valence electrons, you only need 1 more. It's really easy to obtain that. And as you go up a group, the electronegativity increases as well. So this trend is electronegativity. The ability to take in electrons. So the green one's electronegativity. Which one has the highest electronegativity value? It is fluorine. Fluorine has the highest electronegativity of 4.0. But you can find that in the next page. Again, for these trends, we do not look at the noble gases. So this group right here, we don't take these into account for the trends because they're stable octets. They have 8 electrons. They're not going to want to gain electrons. They're not going to want to lose electrons. They're stable. They're happy. The last trend the real trend we looked at was ionization energy. Ionization energy is the exact same thing as electronegativity. What does it mean? Ionization energy means the ability to hold on to an electron. Which one has the highest ionization energy? It's fluorine again. So fluorine has the highest ionization energy. It doesn't want to lose electrons. It wants to hold on to it. It's going to hold on to it really tight. If it has 7 electrons, it's not going to want to give them up very easily. So again, this is ionization energy. Great. Didn't really work out too well there. So ionization energy is the exact same thing as electronegativity. The last trend you should be aware of is metallic characteristic. So this last arrow I'm going to put here, I'm going to start it at my nonmetals and work my way down to the metals. So these guys are the most metallic elements. So working our way down, as you go down this, it's going to get more and more metallic. So metallic characteristics means they're malleable, they're ductile, they reflect light, and they're good conductors for heat and electricity. Nonmetals are the opposite. So non-metallic would be the brown, non-metallic would be the brown, metallic would be the pink arrows. So metallic and non-metallic. That makes sense. Those are the 4 trends that you should be aware of. All right, let's analyze these questions now. We'll hold on to this for a while. The elements in period 3 that has the lowest ionization energy is what? So let's check out period 3. Here's period 3. Elements in the period, the one characteristic that they have that's similar is they have the same number of rings. But as I look at period 3, the lowest ionization energy, oh, there's ionization energy. It's big to the right, it's smaller to the left. So over to the left is going to be the smallest or lowest ionization energy. Which one has the lowest? Oh, it's this group right here. Hopefully recall that is alkali metals. 18 is A. 18 is A. 18A. Next up, number 19. Which element has the least metallic characteristic? Locate them. Least metallic characteristic. Na, okay, that is a metal. Oh, it's pretty metallic. Mg is an alkaline earth metal. That's pretty metallic. It's a metal. Choice C is aluminum. Aluminum foil is pretty metallic. Choice D is Si. It's a metalloid. It's over to the right. It's close to non-metals. It's going to be the least metallic. Number 19, the best answer is D. 19 is D. And 20. The arrangement of elements in the present periodic table is based on its, Tintin says B. This modern periodic table of elements is arranged by increasing atomic number, or they could give you proton number. So this increases by atomic number or proton number. Definitely know that one. Choice B. Number 21, halogens with the highest electronegativity value. All right, so halogens. They're putting a couple things together here. Halogens are group number 17. Which one has the highest electronegativity? Electronegativity was my green. Can't believe the Bills lost yesterday. They didn't really play too well. Whatever. Maybe Mahomes is a beast. All right, highest electronegativity. Find the elements. We have fluorine, chlorine, chlorine, bromine, iodine. Greatest electronegativity. I probably look on the next page and see that fluorine is the highest electronegativity. Electronegativity of 4.0. So if fluorine has electronegativity of 4.0, that's the highest electronegativity. So I probably would go to the next page and say, oh, let me make sure about this. Check out my electronegativity, find those 4 elements, and you'd realize that fluorine is the highest value on the whole chart. Fluorine has the highest electronegativity. Next up, so A for 21. Okay, 10 minutes still. 22, electronegativity values of an element is a measure of the atom's. What does electronegativity even mean? .22. I did do this. A separate chart. There's electronegativity, blah, blah, blah. 0 to 4.0 it said there. And I don't have it in my notes. But electronegativity, anybody? Best answer? Yeah, ability to attract electrons. Choice B is the best one. Thanks, Alex. Ability to attract electrons, electronegativity, the ability to take in electrons. Why is fluorine the highest? Because it has 7 valence electrons. It only needs 1 more. It's pretty easy for that thing to gain another electron. Number 23, elements in period 3 have the highest. Which element in period 3 has the highest first ionization energy? Did we just do this one? No. Similar though. So which one has the highest first ionization energy? There's period 3. Which one has the highest ionization energy? Gotcha. So again, this one I would check out on page 10 and 11. Look at ionization energy. Look at these elements. Look at ionization energy. Look at these 4 elements. And again, noble gases don't. Let's just make sure, actually. Let's go through it before I catch myself here. So find Na, Ar, Cl. So find them. Na. Hopefully you can see behind this little arrow there. I'm not going to get rid of it yet. There's Na, 496. 496. Just get my pen out. 496. Ar, argon. Oh, 1521. bigger. 1521. Chlorine, 1251. Oh, so far argon's winning. And Mg, that's smaller. So yeah, you're right with that. So that one is argon. So definitely check out page 1011. Most of the times they don't follow the trend of noble gases, but in this one, it's going to hold on to electrons easiest. So that does make sense after all that. So choice B is the best answer for number 23. Clear my scale out. Number 24. The chemical properties of an atom are related to the number of its chemical properties are related to what? Yeah, number of valence electrons. Elements in the same group have similar chemical properties because they have the same number of valence electrons. 24 is B. 24 is B. And 25, let's cruise through these. Which of the following elements has the highest electrical conductivity? So 25, electrical conductivity, most metallic. Find the elements. So metallic elements, we have gold. Au is gold. We have iodine, it's a nonmetal. No. We have sulfur. No. And Si, it's a metalloid. Which one's the most highest electrical conductivity? It's got to be the metal. Au is the best answer. A, gold. So 25 is A. 26, nonmetals in the solid state are poor conductors of heat and tend to be what? So nonmetals up here have properties of not good conductors of electricity, but they're also going to be brittle. B, C, and D are properties of metals. 26 is A. 26 is A. 27. I know I'm going fast. I want to make sure I finish it up. 27, which element is a non-metallic liquid at room temperature? There's a question on the midterm similar to this. Non-metallic liquid at room temp. Two metals are bromine, mercury. Which one's a non-metallic? Which one's a non-metal? Brown, bromine. Bromine. Choice D. Best answer. 20. So 27 is D. 27 is D. 28. Which are two properties of nonmetals? Should know they do not conduct electricity. Poor electrical conductors. And talking about ionization energy, which one is it? Let's think. Maybe you want to draw it up quick. Oh, ionization energy looked like this. And it looked like that. High ionization energies. Trace B's best answer for 28. 28 is B. 28 is B. 27 was D, Santino. 29, beryllium's classified as, there's B. Beryllium's classified as an earth metal, alkaline earth metal. And last question, 30, which pairs of elements have the most similar chemical properties? Locate them. Mg and S. Find Mg, find S. They're far apart. One's a metal, one's a non-metal. No. Next, Ca and Br. Find your calcium, find your bromine. Okay, just because they're in the same period doesn't mean they have similar chemical properties. No. Mg and Ca, oh, those guys are in the same group. They have the same number of valence electrons. Number 30, the best answer is C. All right, a lot of talking today. That concludes our review for the midterm. Your midterm is tomorrow. You have the full block to complete it. There's 45 multiple choice questions. You can use a reference table. You can use a calculator. I prefer to have you have your own calculator. But again, you can use the little app that's up here, the little calculator, if you use that all year. Whatever you're used to, just go with it and use it. I'm not going to tell you can't use your phone for your calculator or this little link up here that I'll put up here too. For midterms tomorrow, study up, make sure everything is completed, turned in for exit passes, and your notes, I definitely will make sure that they're completed as well. It's 100 points for this last unit, so please make sure you completed them. All right, guys, that's it for today's class. If you have any questions, feel free to hang out. But that's it. Stay warm, stay healthy, stay safe, study up. See you next time. Bye, guys. Bye, Tristan.